Hello, everyone. My name is Illarion, and I'm a CTO of Xfaang Group. We are a digital agency that specializes in premium lifestyle e-commerce stores. And you might know some of the names. I encourage you to type out the name in Google and check out our portfolio. And I'm particularly proud of the velocity of our development and the fact that we have completed over 50 projects in 7 years. And I'm also proud of the fact that all of those projects, all 50 projects, were fully type covered with TypeScript. So today I would like to share my experience and insights into dealing with TypeScript in advanced scenarios, and hopefully you will find some tips, tricks, and best practices that you can apply in your work. My presentation is going to be divided into two parts. So first, I'm going to cover the tips, tricks, and tidbits that I would like to share with you that you can immediately apply to your work. And then I'm going to do a live demo of a game that I wrote, where I show you how you can encapsulate the business logic. Well, a game can be a business. So I decided to go with a game as a demo, but at our work, we apply it, we use it to encapsulate business logic and represent it as TypeScript types. So so that we are able to statically check our logic in addition to unit tests and other ways of verification. So that would be the second part. I will show you the actual game. I will show you the code, and I will show you the core place where the magic happens. And I hope you will follow along on your computers if possible. So Piotr has shared a link in Slack channel. So feel free to explore the code in the repository. It's publicly available. And if you have any questions, please write them down and join me in Q&A later. So let's start. One of the things that I start is DevOps. So you should be, when you're dealing with TypeScript or any other technologies, the foundation is a good DevOps process, and you should be setting up yourself for success. And TypeScript is no exception. So in our projects, we have an extensive DevOps setup, and as a CTO, it's my personal responsibility to make sure it works fast, and it works correctly. But I would like to share you a short list of the things that has to be there. So I highly recommend using the latest TypeScript version in every project and upgrading as soon as possible. Very rarely there is a reason to stay on an earlier version. And if you find out that some library prevents you from upgrading, it makes sense to reevaluate and see if you can reevaluate the use of that library and see if you can replace it or upgrade it to unlock the new version. So in my demo, I'm going to use the latest one, 5.8, and it does a lot of things better. Next, a good TypeScript compiler options configuration will get you very far. So don't be shy in enabling the strict option and the other things. I highly recommend the materials by Matt Pocock, the author of Total TypeScript course, and they also have a free book available on TypeScript, and they have a TypeScript tsconfig cheat sheet. Basically, you can just copy what the article says, and you're good to go. Now, I would recommend not ignoring ESLint, and I would highly recommend TypeScript ESLint in strict typed mode. So there are 3 modes. So the recommended, strict, then recommended typed, which analyzes the types and gives ESLint much better insight into your code. And then there is a strict type. It can be daunting. So when you're enabling this mode, your output is peppered with errors and warnings, so it can be overwhelming. But keep in mind, even those errors are warnings for you. So if your code works, you don't have to address them all at once, but you already have a purview of what's going on in your code and what can be improved. So now you have a roadmap for the improvements. So don't be shy, enable TypeScript strict typed mode. Also, I highly recommend trying out new tools like Biome Linter, and you can run it alongside ESLint. The checks that they have sometimes overlap, but they also have some additional checks that ESLint doesn't have yet. So by combining two tools, you can get much better results. Especially, I would recommend trying the autofix mode. Just running Biome Linter with a fixed flag will get you another roadmap for improvement, and some of them can be applied immediately. So you just commit the changes and good to go. Verbatim import syntax is important, and there are code mods for that. Verbatim import syntax is when it means that you have to specify that you're importing a type and not a value. So you would write import type and then the type. So it's very beneficial for the new tooling, and it also improves the overall picture in your project. So now you see where are the real runtime values and where are the types that are going to go away when you bundle your project. And last but not least, detecting circular dependencies was the ability to detect circular dependency was a godsend for our projects, because we encountered we were able to solve elusive bugs by just understanding where we import where we import the modules. So module A imports module B, but module B also imports module A, and then the tooling, the bundler, whether you use Webpack, Next.js, whatever, cannot deterministically resolve which one should be first. And that can be extremely hard to debug, and there are specialized tools for that, and they're easy to use, and they can save your hide. So in my repository, I include an example, a snapshot of the DevOps setup we have. Of course, it's a much smaller snapshot. I removed the parts that are not relevant to the demo, but it's open, publicly available, so I encourage you to try it out and see what applies to your work. So this is a working setup I would be confidently using in a smaller project at work. All right, now about type runtime gap. So as most of you know, that TypeScript is not entirely, TypeScript type system is not entirely sound, and that's intentional. So compared to languages like OCaml, where if your program doesn't have type errors, it will never have runtime errors, and that's a guarantee. And in languages like OCaml, it's even verifiable. TypeScript couldn't go that way because it's meant as a superset on top of JavaScript. It was meant to be gradually adopted, and it's impossible to achieve type soundness without sacrificing 80% of the underlying language. But it can bite you in a real work project, because TypeScript is prone to giving up in a situation where a stronger typed language, can I say stronger typed language? In a situation where a language with more type soundness would sound every warning possible. So there are a couple of tips I would like to share you that can dramatically improve the quality of your code and eliminate the situations where the the compiler says everything is all right, but at runtime you get errors. So first and foremost, please try avoiding type assertions. Type assertions is a bad name. I keep explaining it to my team. Every newcomer gets a lecture from me on type assertions, because type assertion term means a different thing in different languages. For example, in OCaml or in ReasonML, type assertion, it means you're basically saying to the compiler in those languages, I'm not sure what type is it going to be. Please infer the type for me. So like it's a placeholder. While in TypeScript, it's a directive. So you say, compiler, listen to me. I know what I'm doing. Just go for it. Compiler says, all right, all right. And now we have magic like this. So you can see before I'm doing JSON parse. I'm trying to parse one as a string. It's going to be parsed as a number because according to JSON, this is a number. So A is actually a number, but there's the magic type assertion. I say, but I as a developer say, it's going to be a string. The compiler complies. And now you can see that when I do a type of check, type of A equals string, it's true at compile time. So it is a string in the eyes of the TypeScript compiler, but it's actually false at runtime. So what I'm saying to my team, if you lie to the compiler and you're making your own guarantees, you as human guarantee that this is going to be a string. But we make mistakes. We have computers to help us avoid mistakes. So there is no reason for us to feed wrong information into the system. So if you feed wrong information or if you lie to the compiler will start lying to you back, even if it doesn't want to. So instead, it's better to use type guard functions. Type checks like type of is a form of type guard. So here in the after example, you can see that I parse the value into a temporary variable, and then I check if it's going to be a number, then it's a number. If not, then I fall back to null. And now I can handle it much better in the follow-up code. So if B is null, I can handle it gracefully. At least I am as a developer, I am aware of this possibility. So parsing libraries help a lot. You can run a you can write a parsing function yourself. So let's say I feed a number, it checks internally and maybe coerces it to a number. You can go as far or as little as you need, and then it outputs the right value. But it can be hard to write those manually, so I highly recommend using parsing library like Zod, Superstruct. I think the newcomers are Valleybot, and well, feel free to remind me of the last one, but it's quite popular now. It's gaining popularity. Zod is my personal favorite, Z-O-D. Now, next, you probably saw the code on the left in your project. You might have even written something like that. So you have some custom value which is available in the browser on the window object. So let's say my global stuff, and you would like to access it in TypeScript. And if you don't have the code on the left or on the right, TypeScript is going to complain and it will say there is no property my global stuff. There cannot be a property on my global stuff on window, and now you have to deal with it. And so most developers turn to global declaration. So they write something like this, either in their own module or in the DTS file somewhere. So they write declare global interface window. Well, the stuff works, but now everyone gets it. So your module gets it, my module, I don't need my global stuff. I might have a different idea of its shape. I mean, for my part of the code. But now I have it anyway. And as I will show later, interfaces compound. So interface names are global in TypeScript, and that's another gotcha. Now you get all kinds of stuff. So I very much prefer the variant on the right, where in your local module, you define what you need and it stays in your module. So this is a local declaration. So this line declare let window, and where you define which type it's going to be, it's going to stay in your module and your module only. So if another developer has a different shape, they will never clash. They will never conflict with what you have. And it's also explicit, so you don't have to hunt down the global declarations across the code base and then negotiate changes with other developers, because everything is scoped to your project, to your module, sorry. All right. Now, I'm going to do a shuffle a bit. Since we were talking about interfaces, and I think this is more important to highlight now. Interfaces in TypeScript are global. So when you write interface my thing and you like ID, and then you have another declaration for the interface with the same name, they will combine. That's how TypeScript works. Interfaces are global. The names are global. So they extend each other. So you don't have to use the syntax interface. My thing extends my other thing. It will work implicitly. Moreover, in this example, they are right next to each other, and it's obvious that you can combine them. So it's obvious where the problem is. But it happens across modules. So if someone writes interface JSON, innocent enough, it will affect the fetch outcome. So the fetch utility returns a JSON interface type. So you will change the shape for every fetch request. And if another developer declares the same thing, they will get whatever you declared before them. And yeah, it's going to a mess. So I highly recommend using type aliases. So there is a lot of contention in the community about interfaces and types, and you can see a lot of discussions on that. But I'm sold on this thing. I want isolation. I don't want my type declaration to affect other declarations, and I don't want other declaration to affect my types. So it's not about stylistic preferences. It's about a clear after effect of the thing. Now, yeah, I'm jumping a bit, but it makes sense. Type resets. So this is a very useful thing. Please visit this link. The article is comprehensive, and moreover, it supplies a library that does most useful type resets for you automatically. So for example, any fetch request returns any type when you do response JSON. So you can do whatever you want with the response, and the compiler will stay silent for the whole duration. JSON parse does the same thing. So similar to what we do for CSS, like there is a CSS reset, there is now a TS reset where you make those types stricter. This project sets it to unknown, which is a safe type. So when something is marked as unknown, you have to parse it somewhere in your project before you can use it. In my projects, I prefer to assign a special type called JSON value, which represents a JSON value. You can see that in the demo repository if you're curious. And now for the easy and cheap thing that might change your life. So I really, really like it. TypeScript doesn't have built-in exhaustiveness checks. So for example, if you have input like this, it can be A, B, and C, that the compiler by default will not tell you that you're not handling one of the possible values when you're writing your code. But in the newer versions, and this is why I highly recommend upgrading to the newer versions, with a single line like this, input satisfies never, you can add an exhaustiveness check to any expression, any if statement, switch statement, or even expressions if you take time to create a special utility. So here you can read that we have an input A, B, C, we handle A, we handle B, and then we fall back to default. But as developers, we would like to be sure that we handle everything before we have a default. So the default itself is a escape hatch. So ideally, we should not have a default, like a fallback value. So, and this is where we can at least add a check for ourselves. So we write this. So at this point, input should be exhausted. So this expression, input satisfies never, means that there are no values left in the type. So we take, and now I cannot say it's empty. It's this special type called never. So we cannot do anything about the type anymore. In our case, this works in our advantage because we can specify input satisfies never. And in this case, we will get an error because we forgot to handle C. As soon as we add a branch for handling C, the TypeScript error will go away. So this is very powerful. This is very useful. You can even do a variation of this. For example, at this point, we can, for different reasons, we might want to do input satisfies C. And that will also work as an exhaustiveness check. But this way, we don't have a fallback value. So the Z will be, the Z return will be a variant for C, and there will not, we won't have any fallback. So I would recommend exploring this. This is easy, this is cheap, you can immediately use it, it's available in the language, and this is the single most powerful quality improvement you can make. Now off to the fun part for the demo. Business logic with types. I encourage you to open a link if you can, but I'm going to share my terminal, my VS Code window, and I'm going to walk you through some of the code, and I'm going to show you a demo of a game, and we're going to build, and I actually build my own blackjack. All right. Let me remind you the rules of the blackjack. I used AI. I used ChatGPT to give me an outline, so my knowledge might be incomplete. But this was enough for me to model the game. So we have a player and we have a dealer. The player can do two actions. First, the dealer and the player get two cards at the beginning of the round. We can have as many rounds as we want until we exhaust players' money or until we exhaust the deck. We can start over, but we have a round. At the start of a round, the dealer gets two random cards and the player gets two random cards from the deck. Now the player makes their move. They can either say hit or say stand. If they say hit, they get another random card. If they say stand, they don't get any card, and now it's dealer's turn to make a move. The dealer is constrained. The dealer cannot make a choice. If the overall hand value, the value of the cards that the either dealer or the player has, if it's lower than 17 points, they have to hit. The dealer has to hit. If it's over 17, the dealer has to stand. So the rules are simple. So basically, the dealer is the computer in our case. And then we have a tally. So after a player and the dealer make the move, we calculate the hand value. The cards have value. Cards from 1 to 10 have the face value. Then Joker, Queen, and King have 10 points, and Aces have 11. Then we have a tally. So if the player has over 21 points, they lose automatically. If the dealer has over 21 points, they lose automatically. If the player, if one of them, if both of them have less than 21 points, then the one with more points wins, and then we can have a tie, and then we do another draw of the cards. So that's the thing. If you look at the diagram, some people might realize that it's a state machine. Martin, where are you? That's for you specifically. So this is a finite state machine. So we have a clear, multiple states, but they are clearly defined, and we have clear transitions between the states. So if you look closely at this, you can see that we at the start we have a new round, then we transition to player decision, then dealer decision, then we have a tally. The tally decides where we go next. So dealer busts, player busts. We have a higher hand, and we might have a tie. So in the first three, the round ends. We define a winner. In the first two, it's clear what happens. In the higher hand, we also have a value that says dealer has the higher hand. or the player has a higher hand, the tie starts the thing over. So we are back to player decision, and on and it goes. Then the new round begins, and so on and so on. The fun part here is that this diagram looks hand-drawn, and I highly recommend Normal tool, where you can define, it's similar to Mermaid.js if you tried it, but I like the syntax better and the outcome better. So you can write it by hand, but this is generated from the code. This actually represents my code. And before I move on to the code, I want to show you the game. Now, I'm running this in Docker, and the repo includes instructions for running it in Docker. And now I'm going to do npm start to start my blackjack game. All right, so welcome, starting new round. Dealer has joker and 5. My cards are 10 and 2. What's your decision? Hit. Yeah, some more. I try my best, but I think this is as much as I can go. How about this? No, it's so starting a new round. The round I won. Starting a new round. Dealer has 5 and jokers. I have 6 and K. I do hit. Dealer wins. Hit. It's a tie. Playing around another round. Dealer and player has, both of us have cards. Hit. Dealer wins. All right, let's try stand. Stand. You win. Nice. Sorry, I did hit. Dealer wins. Stand. Another dealer wins. They have the higher hand. Stand. You win. And so on until I get tired. Now I just can do quit, and it's done. Let's take a look at the code. Piotr, how much time do I have? 1 minute. All right. So I guess I will leave you to exploring. I will leave you to it to explore the code on your own, but I wanted to show critical things. So everything is contained in this demo folder. So this is the loop. So this is a technical part where I use a special library to do that selection thing. The prompt, I should have called it the prompt. I called it ask, but never mind. And I also have print cards, but you can see the actual running loop. While running, if the state step new round, I infer next state from that special wizard utility. If the step is another player decision, I do infer state. You can see that I'm not doing any calculations in the loop whatsoever. I'm just orchestrating the actions. Infer next state, infer next state, infer next state. So you can see that the primary loop is very simple, and it's similar to what we have in React. Like this is a visual component, basically. So there is no logic whatsoever, just messages. And if you look at that, you cannot even say how it transitions. But if we go here and we have a wizard definition here, this is where I define things. So this is the wizard state, all the possible wizard states or state machine states. So I have a new round step. I extracted it for purposes. And then we have, when we are on a player decision, we have the deck. We have player cards, dealer decision, tally, tie, and as you can see, the last steps don't carry player cards, dealer cards, deck information because we don't care at this moment. That moment, the round has ended. And now let's take a look at the logic. So I'm using a special wizard config utility that I created. I wrote it by hand. We have a more sophisticated version that we're using in real projects, but for the demo, I pared it down to highlight the fact that I'm doing a lot with the types. So this wizard config, first you specify initial step. Wizards have to have a single starting point. Yes. A single starting point, and then you can have nodes and tails, like endings and anything in between. And you can see that I'm declaring it here. So navigation, where it can go, and then I define logic when it will go there. So here I define, so from the new round, we go to player decision. The logic for the transition is very simple, but let's take a look at the player decision. So it goes to dealer decision, but you can see that this is where we take the card. We have to, if the person says hit, we take the card. If not, we transition to dealer decision. But this is where all the logic is encapsulated. And it's much more interesting to look at the tally, because this is where the calculations are. So if hand value is over 21 player bus, and so on and so on and so on. Moreover, this is unit testable because this helper is stateless. I'm sorry that I don't have enough time to cover this in depth, but I encourage you and welcome you to explore the repository. I try to make it as self-explanatory as possible. You can see that there is a test for the cards. So you supply the cards and see how the tally responds. So you can write unit tests for the logic. And one final minute to show you the wizard config. And this is where the TypeScript magic is, because when you define a head step, it will follow you throughout the definition to ensure that you don't mark the head as a tail, for example. And I do that through types. And you can see a lot of special utility types like extract, exclude, so on and so on. It looks like magic, but it's readable. And moreover, it's types and it's provable. So you can see the outcome and you can modify it to your needs. So this was a huge improvement for the wizards that we built. Wizards seem mundane, but they're everywhere and they're notoriously difficult to implement. So as some of you know, I love wizards and I love talking about wizards. You can see I'm wasting time. So I believe that types give us a possibility to encapsulate business logic in the most efficient way. So I welcome you to explore it. Now for the Q&A, I'm ready for any questions, and I added some conversation starters for the networking session.
Yep, thank you for the talk. As far as I can see, so you made your own library to do state machines, right? Have you ever considered using something like XState, which has all the benefits of big ecosystem and even allowing some completely non-technical people to build state machines?
Very good question. I love XState and I love Stent, another less known library, but yeah, those are great when you're building a state machine that interacts with that acts as a hub. So XState can invoke actors and other things, but it's a generic tool. And in this case, I wrote a highly specific thing for the wizards. As I said, wizards have rigid rules: head, multiple nodes, multiple tails, and the game is a wizard. A wizard form. So whether you're submitting a newsletter, you're signing up for a newsletter, or you're building a blackjack game, it's a wizard. So in our case, in my case, it made sense to create a custom, not even a library, but a helper. I cannot say it's a library because it's highly specialized. It's just a module that I'm using for my work.
Great applause for Illarion. Woo!